Hi everyone. Today I will discuss about the topic in a transducer system, that is bellow pressure gauge. So in previous presentation we have seen about the Bourdon tube, that is also pressure gauge. So now we will see the next pressure gauge, that is a bellow pressure gauge. So in this presentation we will cover these points about the bellow pressure gauge, that is introduction of bellows, then construction, then working, advantages, disadvantages, application and selection criteria for bellow pressure gauge. So now what is bellow pressure gauge? These bellow pressure gauges are used to measure all types of pressure such as relative pressure, absolute pressure and differential pressure. Means it is more sensitive than the Bourdon tube and it measure the pressure up to 40 mm of Hg. Means especially useful for low pressure application. And one more thing about the bellow pressure gauge is it is unsuitable for transient measurements because of larger relative motion or mass involved. So now construction. So here we can see the schematic diagram of bellow pressure gauge. So the materials used for the construction of bellow pressure gauge are stainless steel, phosphor bronze, beryllium, copper, alloy of nickel, etc. Means these materials have long length and made up of the metal alloy which is ductile and retains its properties over long period of time. Okay, so it is constructed like it is a thin walled cylindrical structure. We can see that cylindrical structure with um, um, sorry so it is thin walled cylindrical structure with number of folds. These are the folds. Okay, these are the folds for its cylindrical surface. So these folds are called as a convolution and these folds can vary the number between 5 to 20. So as if there are more number of folds, then measure larger stroke length and they generate larger forces. Okay, and diameter of the bellows ranges from 7 millimeter to 150 millimeter and wall thickness ranges from 0.08 to 0.3 millimeter. So this wall thickness I haven't mentioned here. Okay, so this is a whole construction and this is a spring arrangement is also there and pointer is attached to this connecting link through this sector and pinion gear, and this scale is calibrated in terms of the pressure, and this means this scale dial is divided in many sector. So now this is a whole construction. So now working principle. So the most of the bellows are spring loaded. Means because of this spring loaded, this helps in preventing the full expansion of the bellow, and limit in expansion prevents the bellows from damage and improves its service life. Okay. So how it works? So we can see the pressure connection here. So the pressure which is to be measured, this is unknown pressure. We have to apply from this here inlet, and because of this movement will occur, this movement will occur and this movement is transmitted to the linkage. Means this linear movement of the bellow is then transmitted to the linkage. Means movement of the bellow can be converted into the displacement. Okay, and this displacement is indicated by the pointer which is contact with the linkage to display the accurate pressure measurement, and this displacement can be converted into the pressure. So this is a simple working. Okay, so now working principles. Okay, so this formula to measure the displacement, axial displacement. So d is equal to 0.453 pb and d square, square root of 1 minus this is v square divided by et cube. So where P is applied pressure, then B is the radius of curvature of each corrugation, means these folds. Then N is the number of semicircular corrugation. Then T is the thickness of bellow wall. D is the diameter of bellow element. V is the Poisson's ratio, and E is the elasticity of material. So this formula is useful in to find the axial displacement, or in gate examination there are many questions asked related to this formula. Okay, so this is useful in every examination. So now absolute pressure. So means, as I told you, this bellow pressure gauges are used to measure absolute pressure, differential pressure and relative pressure. But how? So, so I will explain. So absolute pressure, so this absolute pressure is the pressure with reference to perfect vacuum. Means when we are going to measure the absolute pressure, then it refers to the perfect vacuum. Means two bellows are involved. So we can see in this figure two bellows. Sorry, two bellows are involved, and this is not equipped with spring. Okay, so mostly used for low pressure application. So first bellow is used as a reference, which is a perfect vacuum, we can see in figure, and second one is subjected to the process pressure. So this process pressure causes the expansion of the bellow, and then movement is transmitted to this pointer. Okay, this pointer, and we can measure, or this pointer indicate the change in the pressure. So like this we can measure this absolute pressure. Now differential pressure, so this name suggests that it gives the difference. So it gives the difference of low pressure and high pressure. Okay, so this differential pressure we can measure with single, otherwise dual bellow. So here we can see there are two bellows. So one bellow is connected to low pressure and second one is the high pressure. Okay, so as both forces act upon the bellow, then resultant pressure causes the movement of this bellow, and this in this sorry this pressure is resultant pressure can be shown in using this pointer, and we can measure the differential pressure. Now the relative pressure, like this, here the relative pressure means compression or expansion. Means we can measure relative pressure in high pressure application, or low pressure application. During high pressure application, this process pressure is exposed to outer side of the bellows. When we are using in high pressure application, then we are exposed, this pressure is exposed to outer side, and because of this bellow will compress. And in case of low pressure application, this process pressure is introduced inside the bellows, and because of this will extend, and this compression and expansion movement is transmitted to this pointer to indicate the relative pressure measurement in the system. Okay, so like this we can measure relative pressure, differential pressure and absolute pressure. I hope you understood. So now selection criteria. So in this we can we will see the means which factors affecting during choosing this selecting bellow gauge. So first one is gauge material. So the material which is used for the bellow pressure gauge, this should be chemically compatible with media used. Means this media should be corrosive or neutral. Okay, so because of this we can use stainless steel, then inconel, brass, beryllium, copper, phosphor, bronze. Okay, so they have ability to withstand with corrosive as well as neutral media. So stainless steel is the perfect choice for the corrosive resistant properties. Now second one is the gauge diameter. So these bellow gauges are available in wide range of diameter. Okay, but we can select as per our space limit and readability requirement. So these are available from 1 to 16, that is 25 millimeter to 406 millimeter range. Now the pressure range, like this. So to ensure the safe and stress-free operation, it is important to consider the maximum and minimum pressure ranges of the application. Means this maximum operating range means pressure should not be exceeded than 75% of the full scale range and 65% of the pulsating pressure. So this pressure should be between 0.2 to 1 kg per centimeter, that is 2.8 to 14.5 psi. Now hysteresis. Hysteresis is caused when the pressure sensing element, that is bellow, is reluctant to return to its original position once the pressure causes it mechanical deformation. Okay, generally metal bellows are preferred in pressure gauges as they exhibit the negligible hysteresis as well as long as deflection is kept beneath the elastic limit. Okay, that's why these materials are used, because they have less hysteresis. Now fabrication, bellow fabrication. So as I told you, this is made, bellows are made from the thin walled seamless tube with wall thickness typically ranging from 0.008 to zero point 0.3 millimeter. That is the wall thickness. Okay. So this phosphor bronze bellows provide the good hysteresis properties, and stainless steel also good corrosion resistant properties. But stainless steel, this material have what can I say? This less elastic. Okay, stainless steel. Now the advantages. So compared to other pressure gauges, this bellow pressure gauges provides the advantage of low cost. Means this have very low cost. Then it also provides the excellent pressure measurement for low to moderate pressure ranges. Then also used to measure the pressure of absolute, differential, relative pressure, and it is able to deliver the high forces. Then disadvantages, it requires ambient temperature compensation. Then it is unsuitable for very high pressure application, and availability of construction metal is limited. Now the application. So these advantages make bellow pressure gauges suitable to use in application including heating, ventilation, air conditioning equipment. Means normal bellows are used in airbag in car. Okay, that is a polyvinyl bellow. Okay, and in aerospace system, bellows can be help to prevent the equipment from abrupt failure due to high or low pressure. Means as we know that bellows can act as a pressure sensing element. Okay, so they can be used to measure uh, or check the sudden pressure rise and drop, and because of this will help to prevent the equipment from abrupt failure due to high or low pressure. Also in speed detection system, so pressure fluctuation takes place in several parts of the aerospace equipment due to speed variation, and using this bellow, this can help to sense the minute changes in pressure in the speed detection equipment. That's why in aerospace system for speed detection, these bellows can be used. Okay, then electrical interrupters, and we can measure also flow of water in peaceful river. So thank you guys. If you like this video, then like, share and subscribe to my channel. Thank you.